that of course, since we have a scale out model, so you are automatically creating multiple instances of the function. So that take care of many deploys in that perspective. Dependencies. Here Lambda does not support implicit dependencies anyway. So any Lambda function that you build, if there are any dependencies, you have to explicitly package those. So that is enforced by the system. So there is no common you cannot refer to any because you don't have access to underlying infrastructure. You cannot assume that any dependencies might exist on that system. So that is something that you have to package in explicitly. What you can also do, how you can manage those dependencies also, if you have common dependencies, for example, that could be shared by multiple functions. There is this feature called Lambda Layers, which allows you to define common dependencies in a layer. For example, if your runtime has a library that you want to use, either for the third-party access or something. So you can define that in that library in a Lambda layer, and then you can attach that layer to each function when you define it. So, and that is version controlled separately. So you can maintain version for that, and you do not have to have the function code worry about it. For each function that you create. So, coming to config, again, since Lambda functions are stateless and event-driven, you are not storing any local, or you're not supposed to store any local information there. So those Lambdas does support environment variables that you can basically use to have the Lambda function behave differently depending on the environment. So, for example, if you're running the same function in dev, stage, or prod, your environment variables can actually contain your connection strings or other key value pairs that define the environment that they're in, and so that completely becomes outside of the Lambda function, the main function code itself. So again, it goes back to the concept of immutable code. Just like in containers, you build a container and you promote it across various environments. Here, you can build a Lambda function and promote it through various environments, pre-prod and prod environments, without worrying about change in behavior. All you need to do to have it behave differently is use environment variables. You can also encrypt those environment variables so that using KMS, so you don't have to worry about if there's some secrets you want to store, you can store secrets there as well. And of course, there are external services such as Secrets Manager and Systems Manager parameter store if you want other places to store your secrets as well. Now, backing services. If you look at backing services, it talks about backing service. The concept talks about you should treat all services as the same, right? Now, in the case of Lambda, you are not allowed to run any local processes or any other services, unlike you would do on, let's say, EC2. So effectively, that means what happens there is that all access, including databases, third-party API calls, are all externalized, and you typically access them through API calls over HTTP, HTTPS. So since what we use for that is URIs. So any backing service can potentially be swapped out. One instance of backing service can be swapped out for another, without change in the code, along with environment variables and so on. So again, build, release, and run. There's recommendation. The standard CI/CD best practices apply to Lambda functions. And as I described, functions can be treated as immutable by exposing your environment-specific variables into environment variables there. So you can promote the code through environments, the pre-prod and prod environments, and you can use the standard code commit, code pipeline, and code bit tools for that. Now, in terms of processes, So the reason there is 7.5 factors is because this requirement does not apply to serverless is because this is already enforced by the platform. Lambda functions are stateless and do not share any data, so you're not worried about enforcing statelessness as such. So you're anyway storing all data, in fact, in databases or caches or any third-party backing services. Port binding, similarly, since we are not exposed to any local networking to the functions, again, the way to access any external service is through APIs. So here, port binding becomes kind of redundant. Instead, what you're looking at is invocation models, which I talked about. So synchronous, asynchronous, and stream-based. Those are the ways you can actually do invocation of the function itself. Scale concurrency, again, scale out is default, so you don't have to worry about there's not a choice here. So in terms of how you would in terms of scaling up or etc. Right? So you effectively you are scaling out functions in terms of how many instances that you can run at the same time. So and that you can enforce or manage that by setting concurrency limits, so which can inform AWS that how many function instances do you want to or invocations you want to allow concurrently. Here, the provision concurrency is also a concept which is interesting because I was talking about cold starts, but if your application is a bit latency sensitive, you can just like you do with maintaining an Aws or auto scaling group in EC2, you can maintain some bare minimum provision concurrency so that you do not have initial cold start issues with your app. But that's again something that you can think about as part of your architecture, and take into account and design that into your application. Again, just quickly moving through disposability, that is part of the Lambda architecture itself. It's event because it's intrinsically event driven. So besides the cold starts, shutdown and starts are fairly automatic there. So for dev prod, keeping those environments similar, you still can use the function code remains the same, or you can use CloudFormation to just as you use in other environments to make sure that your environments look exactly the same. Now, what Lambda also brings is there's a framework called Serverless Application Model, or SAM, which allows you to basically set up a deployment of functions along with CloudFormation for an environment across multiple environments. And there is a feature in that called SAM Local. It's been renamed to SAM CLI, which can actually allow you to run and test your functions locally on your machine as well. So you have DynamoDB local, you have SAM local, and this allows you to actually test your functions on your local dev machine even before you get to pre-prod and prod environments. So logs, again, event streams, again, this is the best practice for modern applications. Logs, the good thing about Lambda is that logs are not, you don't have to explicitly create, logging statements. So, in Lambda, the, standard out, you basically push your logs to, your promise to standard out, and, the Lambda management layer kind of actually takes that and pushes that to Cloudwatch logs by itself. So that is not something that you have to build in or worry about directly. Admin processes you're not worried about because again, Lambda, like I said, is versatile. So if you want to run admin processes, you're not kind of trying to run, unlike EC2, you might be running some cron jobs locally on some application servers. Here you can just create those Lambda functions and trigger them from a cron directly without having to be in the main application workflow. So So having just quickly defined like how the principles, how the 12-factor applies, let's look at some of the design principles and across our 5 pillars that we have in our well-architected, right? So the one thing, the first is, and more important is, how do you manage capacity, right? Now, I talked about cold starts. I talked about the fact that you may have applications where users may make up. They may be steady usage, and they may be burst usage that may come in. Now, here the important thing to manage is basically you have to look at there are different states, right? So if let's say if you have burst capacity, if you have say burst requests coming in suddenly, then you have to basically your functions and you have to scale out. Let's say in Dynamo you have fixed read capacity units and write capacity units. Those may be may not be sufficient. So but what you have to kind of size and tune is to make sure that when you are testing your application, you make sure how much traffic do you expect, and basically set your provision capacity on your databases, on your Lambda functions accordingly, right? There is still some burst capacity. For example, in Lambda, you have a burst capacity that can help you initially kind of ramp up, and after that, up to the fact where you've set your limits for that function. So I mean, was somebody saying something? Sorry. Okay. So, so the idea here is that you have to, basically worry about both steady state as well as burst state, right? And you have to. The thing here is to kind of when you set this up, you have to load test it, and you have to monitor the application performance and behavior, and tune the capacity based on the utilization. So a thing that happens here is, for example, you might start with let's say a low memory configuration in Lambda, which basically you might think that okay, that's the memory I'm allocating, but you might find that actually runs longer and causes it ends up costing you more. So when you do load testing and you monitor how the performance happens, so you may find that a higher memory configuration, even though it might seem costly, but it might actually execute your function quicker and actually end up costing less. So this is a cycle that you have to do to arrive at the optimum performance profile in your application. So, for example, like DynamoDB retains has up to like 300 seconds of unused read and write capacity that can handle occasional bursts over and above what you have provisioned. And Lambda also supports initial burst capacity of 500 to 3,000 different invocations depending on the region that you are in. So another thing we want to talk about here is the fact that while you want to be responsive to your applications, you also want to fail fast. So in the sense that you do not want to be, let's say if you're making your application code is making a backend request, you do not want to wait endlessly for it to respond, for some service or a database to respond to kind of get back to the customer, because so that kind of calls for two things. One is that you should make your requests and transactions asynchronous, so which means non-blocking. So you send a request, you start off a request, but then actually use queues and actually use callbacks to inform the end the client app that yes, some data is ready, and then the client app can actually go and pull the data once instead of actually having a blocking transaction, because that has two parts. One is the user experience gets deteriorated, and two, I mean, if your functions are running and waiting, you are paying for them, right? So instead, if you kick off a request and pass it off to a message queue and then invoke you wait for data to come in and then inform the user, then you are not getting into those issues. Also, basically, the fail fast part also was that in case you are not able to process some data properly, you actually, even if it has to be blocking, at least execute quickly, and instead of doing figuring out an optimum time of retry, just exit and let the client app know that yes, this has failed, so please retry using retry your request after a while. And this becomes important for distributed apps, as well as to allow to not let backend systems get completely throttled while just waiting to execute. So another way to kind of actually allow short timeouts basically is to kind of reduce and optimize dependencies. So you do not want to just bundle libraries in to your functions where which may not be needed. So you want to again do application profiling and make sure that you just have the kind of libraries that you need in your app. And here, in addition to Lambda, I mean, Cloudwatch logs and Cloudwatch metrics generally play a very important role to kind of help you tune your application profile and your function code appropriately. Now, another important two aspects are basically the ability to handle errors when they happen, and optimization, right? So like I said, remove unnecessary dependencies. And what happens where you are failing, but you want to not block end user, but you still want to do some sort of processing for that particular request, and especially when that request probably is invoked asynchronously. So let's say an S3 bucket gets a file, it invokes your function fails. Now what do we do? There is some error in the function; it's not able to process due to incorrect permissions, right? So instead of losing that event altogether, what you can do is basically use something called dead letter queues. Dead letter queues actually allow you to they just think of it as an SQS or a Kinesis. You can dump in a message saying that okay, yes, this transaction has failed, and you can in a backend have a separate process to handle, maybe it can be, triggered once in a day. It can be, triggered as a separate workflow. But however you choose to do that, it can process these as, a separate workflow altogether. And so, for example, right, let's say you are trying to, complete a purchase, you're trying to complete a purchase on an app store and on an app front, right? Storefront. And then suddenly, you get an error. You're not sure if your, payment was done or your order was processed. So you can actually, method, a process to reconcile that, the orders in a backend using a dead letter queue could actually help you, execute that, even though, the front end, you don't want to keep the user UI waiting, right? So when we are talking about using retry logic, but then what happens if you let's say even within the your function code or the client you let's say the typical way is okay, it didn't work, your request failed, you retry immediately, maybe for a given number of times, which is good, but you also have to make sure that if you use it indiscriminately, you might end up swamping the system, because let's say there is a bug and your 1,000 requests fail, and they are going to try, basically all 1,000 will do a retry, and then there's already the next 1,000 come in. So your system will immediately kind of have a cascading effect. So we use exponential backoff, which means that when you want to retry, you just don't try at a fixed time. You actually randomize the time between, let's say it could be, just as an example, between anywhere between 2 to 5 seconds. You randomize that so that the requests that you are retrying actually kind of get spread out over a given time rather than hitting the backend completely. And even then, if your functions are calling other functions, other services, you have to realize that yes, if you are if things are not working, then you want to be able to use a design principle called circuit breaker, which means say, okay, this function is not available, right? This service is not available. I will not process, send any more requests to this for a given amount of time, right? So that circuit breaker design can be applied to certain, so that you avoid basically cascading failures down the line. The other good thing to also, when you're passing on, error codes back, to your client apps, to make sure instead of generic error, server error codes, you can actually also give specific codes with throttling. That this would allow your client code to be to know that, okay, yes, my backend system is throttled, so I let me back off for a while, and instead of just keep bombarding the backend with more requests. So in terms of timeouts, so timeouts are a little bit interesting, right? Because you do not want max timeout all the time, because then you are paying for your application function code is just paying. You're paying for your function waiting for results, right? So you do want to keep minimum, but not so much that even intermittent errors or some delays cause functions to time out. So again, this is part of your monitoring and testing cycle that you should, if your typical, let's say your function is taking 200 milliseconds to execute, then maybe instead of keeping 5 minutes or 200 seconds, find the right limit, maybe 300 or 300 milliseconds, where 90% of function execution happen within that 200 millisecond time. But if some function does take a little more time, then they did not get timed out just because our limit was very strict. So that's the cost versus performance consideration there as well. So from an end user perspective, what you also have to consider is, I mean, typically when we look at average response time, right? But that is a bit misleading, because that does not tell you the skew between how many users actually are having a good user experience versus bad. So P99 basically means that 99% of your users are receiving responses within the limits that you have set. So if you have said that my limit for response for a certain API call is 1 second, then you're saying that if P99, if you measure, you are saying that yes, 99% of my users are able or are not able to get data back within that 1 second time frame. And this is more accurate because it does not worry about this overall skew. It just looks at more of an absolute user experience. Now, just excuse me 1 second. So another aspect here to consider is the languages. Now, there can be a choice. Lambda now today, you can write in multiple languages, including Java, Go, PowerShell, Node.js, C#, Python, and Ruby, right? But some of these are interpreted languages and some of these are compiled languages, right? So there is a difference in terms of how this gets invoked. So compiled languages that will get to have just-in-time compilation will have a longer initialization, but subsequent invocations can be faster. Interpreted languages like Python, on the other hand, will have will be interpreted every time. So they might have a slightly larger overhead, but the performance would be consistent. So when you are designing your apps and you're choosing the language that you want to write, your code in, that is something that is also important to consider when you are looking at the performance pillar. So moving on to reliability. Like I was saying, one of the important parts is to make sure that your system is your application it does not get overwhelmed with either bad actors sending requests or some bugs causing a swarm of requests to come in, or like botnet attacks and so on, right? So, and the principle here is that you are basically, if there is some issue in terms of requests coming in a lot more than what you can handle, then the thing is to control them at the edge rather than let them cascade into your system and cause issues, right? So the one prescriptive way of doing that is so when you use API gateways, and I mean API gateways in general as well, that you can specify things like API keys, quotas, and so on. So the way that works is, so API keys are not a security mechanism, but they are rather basically, so let's say if you are if your client apps include, like an Android app, an iOS app, or a web app, right? And these clients are invoking your API. That is one scenario. Other scenario could be that you have third party, you have exposed your expose your services APIs to third parties, right? And you want to give them a certain service level that yes, you can invoke so many concurrent requests at the same time. So, for example, if Uber or Ola are using let's say Google Maps, so you can say that okay, for this this service tier, I can only give you 10,000 concurrent requests at a time, right? So API keys kind of help you define the client in which your services are exposed to. So when I embed my let's say my iOS my key that's specific that I've created for an iOS client versus an Android client, I know, and then I'm able to tell that if requests are coming in, how many are coming in from a given client, right? And then on that, I can set my quotas. I can say that okay, only allow for both my Android and iOS apps, only allow 1,000 requests across all the users that are using those apps, right? At a given, in terms of concurrency. Now, what this does is that tomorrow, let's say if you have let's say you update an app and you did an update to the app, and suddenly it's kind of swarming the backend with a ton of requests. These quotas will help throttle those requests at the backend itself, and with the usage and the access logs, you'll be able to tell that yes, my this particular version of the app, client app, is causing issues for me. Now, so this way you can have multiple quotas set up, and so you could basically, you are effectively narrowing your blast radius for your backend. So besides that, you can also set your user level limits. So you can say that okay, this particular user can only access invoke so many API calls at a given time, and all of this basically can flow into a global limit. So you might have a global limit of 10,000, out of which you allocate 1,000 to iOS apps, client apps, 1,000 to web, 1,000 to your Android, and then within that you can define each consumer level limits, that each end user, how much limits that they have. So it's just different levels of basically rate limiting. And the important part is that when we do this has to match with your backend service limits. So if my Dynamo, or my Lambda function can only take, I have the concurrency of 500, invocations, concurrent invocations, having, your API gateway defined limits higher than that can cause a problem. So you have to make sure as you test and tune that all those limits are in line, so that you're not overwhelming any particular part of the overall system. Already talked about using messaging for distributed processing, distributed async processing. Now, the important part is we talk about functions are all about just quickly execute, invoke them, execute, and exit, right? But there are cases where you want to manage workflow, complex workflow. So how do you do that? Because functions don't allow you that. And I mean, in the traditional enterprise architectures, you typically have an enterprise service bus. How do you do like complex workflows here? So here's where step functions come to the rescue. Now, step functions basically, let me quickly show you what a step function would look like. Yeah, just right here. So step function basically allows you to create multiple functions, Lambda functions, and then organize them in a workflow. And as you can see, you can it's like a declarative Lambda. It's called Amazon States language specification that step functions use, and it allows you to kind of define the state transitions between various functions. So and how each function and when each function gets invoked. And there are different workflows, including parallel execution, decision tree, and so on, that you can basically emulate your workflow with functions using this service. So, there's an interesting part that how do you handle partial failures, right? If let's say you invoked two services, and one of them succeeded, one of them failed. So you here the recommendation is that handle these programmatically. Do not depend on assume failures in your application code and build workflows accordingly. And step functions can be used in here to actually kind of do orchestration around multiple invocations and help you make sure that you do not end up in bad states. So also, I mean, there is they talk about using saga patterns, which is more regarding the dev side. I don't want to get that into it too much right now, but you can implement those patterns here to handle programmatically any partial failures that might happen. And like I said, so DLQs you can actually also use to handle errors when consuming messages from message queues, so that you do not lose out. Even when you're doing asynchronous processing, you do not lose out on any data that or invocation that you might need to process. So I know I've been talking a lot, so I hope I haven't put you guys to sleep. So let's quickly kind of jump into a quiz, right? I mean, there was a lot to absorb here, I know, but let's. Just 1 second, guys. Give me 1 second while I. So please join in on Kahoot using this pin. I'll give 15 more seconds. I think let's wait for. There are close to 170 people on the line, so let's wait for others to join. Nobody else? Okay, 10 more seconds, then we'll start. Okay, 5, 4, 3, 2, 1. All right. This is all about serverless. So let's see how do we do. This should be relatively straightforward. Okay, only 72 answers. And let's see what we get. So we have 22 people who said application doesn't run on servers. That is not true. Like I mentioned, the first part of my presentation, yes, and everything ultimately does run on servers, so that's not the case. Luckily, nobody selected low-code frameworks. Really happy about that. And like I said, also, so Lambda is the compute part of serverless, and it's been a lot of what we're talking about. But any service that is not does not expose infra to you effectively, think of when you're using cloud service as an API. Think of that as serverless, right? Okay, awesome. Let's move on. Okay, we have Harish, Mrityunjay, Vishesh, Smriti, and Anit the top. Good job, guys. Let's see how we do in the next one. Okay, much better. Awesome. All right, let's see what we have here. We have 13 people who said functions are stateful. No, that is not true. One of the key things, yes, when you invoke, let's say when you've executed a function, one of the function instances and goes back to the pool, there may be some initialized variables left, but you should not assume that any such pre-initialization exists. And when you kind of invoke a warm container from the pool, you should treat it as fresh. So there is basically some initialization that you can, like connection pools, etc., that you can do as part of global variables. But yeah, there is no state within the function itself. And we had 8 people say that function was long-lived. No, the functions are expected to execute and exit. So, high PKSK types. That's what we're supposed to, think of them as. And containers, so they do get packaged in containers, and that was a bit of a trick question there. But that is not something that that is exposed to us. That is more of an implementation internal detail. But yeah, so stateless is the right answer. Let's see who got this right. Okay, we have Mrityunjay move to the top, and we also have Awesome and Franson now on the board. This should be an easy one, guys. Come on. Awesome. Step functions. Yes, 46 people. Really good. That's great, guys. Well, let's see what else did we get. Well, we got 11 for ECS. Okay, ECS again. It's ECS are containers, but not necessarily complex workflows. I mean, you're still the reason on ECS container is called a task definition is because you're still the mindset is of event driven. You're looking at a service as a task, right? So that is not the right answer for our purposes today. Batch again is batch processing. That again is through containers, like I had mentioned earlier. That was a bit trick. Again, there was a bit of a trick, entry here. And Fargate is serverless, but Fargate again is more of an execution. It supports the execution of containers without infrastructure. It does not necessarily support workflows by itself. All right. Okay. So we have a bit of a shake-up here. Awesome at the top. And we have Franson, Harnish, Mauni, and Saurabh. All right, let's see. So how do we launch this rocket ship? How many different ways? Awesome, we're getting good at this. Really nice. So we had, we had very few synchronous stream-based asynchronous, but yes, all of the above is the right answer. As I just explained, so synchronous is when you invoke it through, let's say, through an API gateway. Asynchronous is when either you're running it through cron, or stream-based is when you have queues, or S3. Asynchronous is also from S3 bucket in the video example that we had shown you. And then stream-based is through queues invoking the function directly. So let's see how the leaderboard changed. Okay, still the same 5 people, but a little bit of a shake-up here. I think it's more about fastest finger first right now. Okay, on to the next one. So where can you store logs in AWS? Logs. This is not necessarily a serverless question, but this is more of cool. So here the answer, yes, I mean, you can technically store logs in DynamoDB. I mean, but that's not what you really want to use it for. I mean, you can store, anything in DynamoDB, right? Same thing with Kinesis. Kinesis is more of a messaging platform. So, the retention of, you may push logs onto it if you want to process or analyze them. But, it is not a persistent store. So you can either store logs in Cloudwatch logs or in S3, right? S3, again, you have data lakes where, basically you can do a lot of processing on logs and other data. And Cloudwatch logs are the default destination for Lambda to push logs out to. So those two are the right answers. All right, let's see how did we do. Oh, nice. We have a bit of a shake-up here. And we have 12 players who have answered the last 3 correctly. Very nice. So is it Ant-Man? Is it Gru? Is it Tony Stark? Or is it Samwise Gamgee? A bit confusing here. Okay. So obviously grew and totally were just there for fun. And again, the Java build tool, but not the right one for our purpose. So SAM is the serverless application model. So as I had explained, the serverless application model allows you deployment, using, it supports CloudFormation, and, basically integrates with Lambda. And the SAM CLI also allows you to, basically creates a Docker environment in a local host, and you can, run and test, functions, Lambda functions locally in that. So SAM CLI is the right answer there. Okay, we have a couple of new folks on the board. And Shash. All right. And 4 players with a streak of 4. Very nice. So how do you store environment variables in Lambda? Okay, so environment variables is the right answer. So a lot of folks answered Lambda layers. So Lambda layers are for configuration, basically for your dependencies, and for your, not for configuration, I'm sorry, for your dependencies and libraries and so on. Elasticache, yes, but Elasticache is more of a general, you can store state, contexts, data in there. You definitely can, but for default for Lambda is the Lambda environment variables. Aurora also. Aurora typically, yes, it's more of a database. So yes, you can store environment variables there, but then the interesting question is how do you access Aurora in the first place, right? So again, and in terms of the speed that you want to kind of pull those out. So yeah, that may not be, it can be done, but may not be optimal. Okay, all right. One change on the board. Okay, so I think, yeah, with that, we are end with this quiz. So we have this poll just to quickly understand, like, how are we, looking at serverless, right? Are you getting requests from your customers talking about serverless? Interesting. So 42% is analytics and machine learning. And then we have 13 enterprise apps. That's very interesting. Enterprise apps is 31%, and then consumer and others are at 13 and 14%. This is very helpful, guys. Thank you so much. I mean, it helps us to kind of understand where, even for further enablement sessions, if we were talking about, analytics, then we can probably focus on that, in the next sessions as well. All right, one more poll question. So if customers are asking, what is their main motivation to move to serverless technologies? Okay, 29% want to save costs. 28% they want to scale to be able to meet growth, and 28% to reduce management overhead. Awesome. That's really interesting. Okay, thank you, guys. So let's see who's at the top. Very nice, guys. So Harnish, Moni, awesome. And the 2 other folks. All right. So well played. Now let's quickly get back to let's get back to our other two pillars. Sorry. All right. All right. Back to the boring stuff. So operational excellence, right? So we're on to the next pillar. So what is in operational excellence? What are the design principles that we apply to serverless, and how do we what practices do we use, right? So application lifecycle management. So how do we build, prototype? How do we deploy? How do we promote the function code, the serverless code across multiple environments, right? So I mean, part of this I've talked about already, that we look at using infrastructure as code, for prod and pre-prod environments. Now, traditionally, you would do that in a CloudFormation template outside, but like I had earlier mentioned, that if you use the serverless application model framework SAM, you can it's a simple templatized way which actually converts your function deployment definition into a full-fledged Lambda, CloudFormation template. And it allows you to define your environment variables. So you can actually, if you look at that, you can actually use SAM templates to define multiple environments and then deploy code across that. Now, interestingly, like I mentioned earlier, if you remember the diagram that I'd shown you of how Lambda is invoked, so the actual function code lies in an S3 bucket, right? And that URL kind of goes into the Lambda function definition. So effectively, you can create definitions using SAM for all these environments, but the code, the code reference remains the same. So that's what kind of makes it immutable, right? So keeping secrets outside, that is something again. Hang on, 1 second. That we talked about. Here, one of the things that I do want to mention is from a repository organization perspective. Typically, in microservices, we say that each microservice should have its own repository. So similarly, here the recommendation is that your Lambda function source code should also have a 1:1 relationship between a repo and a Lambda function, right? Environment variables that we've already talked about, how they can help your code behave differently across various environments. So that we already talked about. And standard CI/CD principles and practices apply. So using your code pipeline, code build to your build your function code, and code pipeline to orchestrate the deployment via code deploy. You can actually use CI/CD pipelines to deploy code to various environments. Now, again, in terms of it is also recommended to look at because the functions are versioned, you can deploy multiple versions of the function. Now, how do you want to do A/B testing, where you want to test a certain new functionality with a given set of users? So again, this is not per se something that you would do within, let's say, Lambda, but you can use API gateway, to version your exposed APIs, and then basically, from Route 53, you can actually do traffic splitting, so that part of your part of your traffic goes to the new service, and part of it goes to the old service, and then you can use logging, logs to kind of actually see if there is any change in behavior for users, right, based on the features that you've provided. Account and environment isolation remains the same as standard. So you do want to have dev and prod environments in separate accounts, separate VPCs. that again that remains the same as when we do traditional infrastructure serverless application model, like I've already talked about. And word deployment strategies is something again that we can kind of decide if you want to just replace functions completely and expose update versions of the API gateway directly, or do you want to do blue green where we set up a new pool, provision pool for new function versions, and then basically switch traffic over gradually. So those all of those strategies can be used in serverless models as well. Now, the key part of all this that I talked about, right? One was we talked about load testing, but then the other part, which is very important because you don't have access to the underlying infrastructure directly, is to capture metrics, right? And capturing metrics is very important, and not just system metrics. For basically your utilization, etc. You want to also, because you are using distributed architectures, you want to capture metrics like queue depths for the queues that you're using to make sure that your queues are not building up, and your queues are not getting backed up as well. This is at the system level. From a business metric perspective, you can also build story dashboards. So, for example, if you have a service, a set of services that get invoked in sequence, for a certain workflow, for example, placing an order, right? So you want to not only look at system metrics, but you also want to be able to say that my workflow, what is the health of my workflow? So tracing can help in that, but you can use that to actually build dashboards around saying that, okay, my order workflow is healthy, but my product listing workflow is maybe not healthy because of certain failures in the back. So that not only gives, that gives, let's say, from a business perspective, it can help you understand business impact of specific workflows, end user workflows failing or, getting degraded. The customer experience metrics. So latency, very important to measure. I mean, you want to do that through, endpoint monitoring. You could do that through external third-party tools like PingDom, etc. You want to manage, you have to look at page load times, and P99 metrics. And you also obviously want to, be able to look at, build dashboards around how your A/B testing is changing user behavior, right? Besides that, operational metrics, we recommend capturing operational metrics around, how your CI/CD pipelines are behaving. Are there any build or deploy failures? And if so, I mean, those can get highlighted and alerted on immediately. So that's again more along the CI/CD discipline. Central logging, as I said, in serverless, especially for Lambda, etc. I mean, Cloudwatch logs, are the default target. You can also choose to use, basically push logs out from there into external log sources. And if you want to aggregate and visualize on them, if you don't want to do it within Cloudwatch logs, you can kind of export them to other tools that you already might be having in a customer environment. And then again, because distributed tracing is very important to be able to trace, user flows, basically function flows across your, Lambda functions. So security. So like Ravi was saying, security is job zero. So there's first and foremost is you want to make sure. So we already talked about managing secrets. So that ensures that just helps that make sure that you don't expose any sensitive passwords, etc. outward. Beside that, from a security perspective, you are looking at service level access control, right? Now, similarly, like we have in EC2, you have instance roles in EC2. You also have IAM roles for Lambda that you can use to basically define which other services or other functions that one particular Lambda function can invoke. And here again, the best practice is that you should have a 1:1 relationship with each function. So if you are creating a function, you should create a role specific to that function, because that function will be accessing maybe other functions, queues, databases, S3 buckets, etc. So you want to create a fine-grained, granular set of permissions, and basically make sure that you're not assigning it to more than one function. So you have to kind of get very granular with that. And again, this goes back to principles of least privilege, that you basically do not give more permissions than you need to. For end user, customer, logging and identity management, Cognito is a service that you can use to create user pools. You can also do social logins, etc. through Cognito. If you want to have custom, login workflows, MFA, that is something that we can use Cognito to enable for you as well, using custom authorizers. From an API gateway perspective, just like I talked about IAM roles for Lambda, we have instance roles for EC2. We have resource policies for API gateway as well. So resource policies basically do the same thing. They define that which other endpoints behind within AWS can an API gateway redirect requests to. So that can help you control that, and limit your exposure of your backend services through API gateway. Also, you would be having, when you do services and when you do distributed architectures, environments often have tens or hundreds of sometimes for large customers, like even thousands of services. So what you have to also do is make sure that you separate out services that are exposed to client apps externally versus services that are more for internal processing, right? Or services that get invoked only by the services or by queues, etc. And then define those boundaries around them as well. Now, one thing that you can do with Lambda, for example, is when you deploy a Lambda function, it goes into a default AWS managed VPC, which is basically again multi-AZ deployment, highly available, all of that. But you can also, if you want VPC level controls to be applied, you can also choose your subnets in which to deploy your Lambda functions. And basically then from there on, you can apply your network controls in addition to your IAM access controls to kind of limit how the traffic flows from Lambda to other services or other components of your application. Right. So also from an API gateway, it's great to enable access logs. To make sure that that kind of helps you understand where your requests are coming from and what those requests are. But the only trick here is that do not typically kind of put the access URLs in the log. So if you have any, so instead of putting sensitive data in query strings, either send them in as part of post data, or if you have to use query strings and encrypt the data on the client side, so that those don't get into logs. If they don't get into logs, you still would have to kind of control access to those logs and basically do some data masking on that. But that's not a good practice though. So application level security, right? So now this gets away from the infrastructure side, more into like how from the application side. Now, one recommendation is to obviously follow AWS best practices. Can look at security bulletins and understand the latest the threat landscape. The OWASP top 10, including cross-site scripting and all those, basically you can use AWS WAF or other, application firewalls to, prevent against those attacks. As part of the CI/CD pipeline, also recommended to use various tools, code analysis and profiling tools to ensure that your code is not either contains any third-party libraries or or any other vulnerability that might impact your application code. Right now, one of the things that does happen that you might, when you're getting a request onto your API gateway, you might have requests that are malformed, or you might have not they may not be conforming to what the request types you're expecting. So in API gateway, you can actually define a JSON request model, and you can validate that incoming requests are conforming to that particular structure in your in your request, so that you do not pass any unintended malformed data back to your your backend APIs. And of course, do app-specific validation. Do not, each application is different. I mean, your customer may have different use cases. So, use your judgment to make sure that you are using validation mechanisms appropriate to that kind of application. And so for example, if you're using credit cards, make sure you're encrypting. And not storing, not persisting that personal information, card information anywhere, in persistent storage and so on, right? So, last and not the least, my favorite topic, cost management, right? So, a few things here. So, even though Lambda, can be an integration point between multiple services, but in AWS there are often services that talk to each other directly. So instead of trying to build glue code, if there are direct integrations, use them directly yourself. So for example, if there is integration between, which is there between S3 and Lambda, use that. Do not build a Lambda cron-based polling function to check for new look at new objects updated in S3 bucket, for example, right? For long-running tasks and workflows, again, use step functions. Just because, like I said earlier, if you let do polling or those kind of things within the Lambda function, you are going to end up increasing the cost. Let's say you deploy a function that kind of polls for 2 extra seconds, and you have now 1 million requests, concurrent requests. So you can multiply those 2 seconds by 1 million, and you can see how quickly the costs add up, right? Again, because execution time is money, like I mentioned, global variables are important. So you don't want to be doing initialization of your common things like connection pools, etc. every time. So use global variables to kind of do one-time initialization and then reuse them across multiple invocations. And the thing here is monitor, tune, and optimize. This is a continuous improvement exercise. Luckily now you also have basically what you can also do is you have machine learning capabilities inbuilt into CloudWatch. So what you can do is you can use logs. You can basically pivot them into metrics, and you can build alarms so that if you're, let's say for example, if you're getting a lot of errors in your functions, you can and that is showing up in logs, you can actually build a metric around that to say that okay, if a log that an error threshold increases beyond a certain rate, you can generate an alarm and take action. And because there are a lot of capabilities in CloudWatch now with machine learning, you can actually look at having more adaptive limits and thresholds on those as well. So yeah, that's something that can definitely and should be explored. And of course, tagging, use tagging to figure out. So always like which functions, which environments, that helps you understand where the execution is costing you more money. I mean, set budgets. So I mean, having serverless and having not having to worry about infrastructure doesn't mean you don't have to worry about costs. So always sizing and planning and sizing is always important. So always do that, and plan your budgets in your cost explorer, and build reports around that, and build alerts as well. So make sure that you are setting up those typical 50, 70, 100% alerts, so that if your projected spend is going to go beyond. So catch issues early. And basically, last but not the least, again, there is no substitute. No infra can be a substitute for bad code. So if you take bad code from your traditional infra environment and dump it in functions, you're still going to have problems. So good coding practices, though not a subject here to cover, but no amount of infra can help you if you don't fix if you don't code well. So working with developers to make sure that those code is written well and is conforms to the best practices that we have talked about. That is what's gonna kind of have you an efficient and well cost managed solution. All right, next. So what to do, right? So again, done this, no secrets, no long running code, not depending on function state and tenancy, don't port legacy code as is. I mean, that's just another way of saying that if it is bad code, if it is not event driven, code that is written with event driven architecture in mind, do not just port it. It will take a holistic thinking about distributed architecture, be it functions or containers, to kind of make sure that you're running that efficiently. And do not block. I mean, do not have long blocking, waiting, polling kind of code within your functions. So fail fast that's the other option. So another part is that again, you have to also understand that distributed architectures they have a lot of different moving parts. So yes, there will be a bit of latency as well. So you can do cold, you can do kind of provision concurrency, you can do all of those things, try to prevent cold starts. But you have to understand that there may be some cases where latencies that are added, even if it's tens or 100 milliseconds, that may not be suitable for some applications. So depending on the customer use case, you may have to see if if the customer is really sensitive to latency. Then you have to see that if distributed architectures as a whole and then serverless are the right approach for them. All right, so I'm done with my talking, and I just want to kind of conclude here with another quiz. So let's get into it. This is the fun part, I guess, you've all been waiting for. All right, guys. Let's see. This is the last one. After this, we're done. Thank you for being patient and hearing us out. So let's go out with a bang here. We have 174 people on the bridge, so let's see a lot more participation than we did last time. Come on, guys. Only 91 folks have signed up. We still have 82 people who are not joining. I'll give another 20 seconds for anybody else who wants to join. Come on, guys. Few more seconds. I guess some people are having issues because I see people dropping off and then joining again. So all right, last 10 seconds. I know I said that 20 seconds, 30 seconds ago, but 10 more seconds and then we get started. 5, 4, 3, 2, 1. All right. Okay. All right. Okay. All right. Yes, a few last minute folks. And 1 and 2. All right, guys. I'm getting started now. Did somebody drop off? Hang on. All right. What does scale to 0 mean? Does it mean that I've lost all weight? That would be nice. But unfortunately, no. Okay, let's see how we answer to that. So 46 people said Lambda capacity is released. Awesome. That is great. 16 people said when all provision capacity is utilized. No, that is not the case. Scale to 0 simply means that there are no resources being used because there is no requests coming in. Again, function of having event-driven architecture, right? And event-driven plus serverless, it just means that you only use when you need it, right? Lambda functions deleted? Definitely not. There are no instances, but the function themselves are in the system, right? And 15 people said connection pools are released. No connection pools. There are no connection pools in Lambda. Connection pools are more of a database construct. Here you have Lambda pools, but yeah, Lambda pools are not. The pool is not released, but the pool becomes empty. But this was a bit of a trick thing here. Let's see how did we do. Okay, we have different folks from last time on the leaderboard right now. All right. Next. A cold start is when? Is it when I'm freezing in the morning in the winter? Awesome. 47 people selected the right answer. And so I see you provision the serverless app via CloudFormation. No, that is not a cold start. That is just deployment. When EBS volume is created from snapshot, that actually is interesting because that there is a delay there as well, but it is not called a cold start. It is basically lazy loading of your actual bits from the snapshot when you actually start first read the bit, after initialization. So that's more of lazy loading. And database connection pool is first initialized. No, that is also not true. That is, again, that's nothing to do with Lambda as such. Okay, just see. All right, a bit of a change on the leaderboard. Let's see, how do we do in the next one? SNS is serverless. Is it true or is it false? Any two answers? Yes, absolutely right. It is true. In fact, it was listed as one of the serverless services in our earlier slide. And because you're accessing it through the API, or there is no infrastructure that gets exposed to you. Therefore, it's serverless. All right, Ravi Kumar B, 3 correct answers in a row, and we have a bit of a change in the leaderboard here. Very nice. Okay, now this should be fairly simple. Let's see. This should be 100% correct. All right. We still have a few people answering the other ones, but yes, operations, reliability, performance, cost, and security are the 5 pillars of the well-architected framework. All right, guys, awesome. Cool. Aditya leading the board, Naveen, Shash, Santosh, and Franson. All right, let's go to the next one. So which AWS serverless services support provisioned and burst capacity? There can be multiple correct answers for you. Awesome. So DynamoDB has basically provisioned capacity, which is your read and write units. That's how you, and the database size. And but it also supports burst capacity. Lambda, obviously, you have reserved concurrency, you have provision concurrency, and you have the initial burst concurrency that from 500 to 3,000 requests that you can invoke when you're starting up. Okay, we have a bit of a change, but in terms of 4th and 5th position, and we have 3 players who dropped their streak of 4. Okay, interesting. Let us see. AWS Cognito can authenticate users via facial recognition, social logins, IAM credentials, SAML federation. All right. Cool. So social logins, which I talked about, and SML federation, which basically, you can federate through, either Active Directory or any other, source that supports SAML. Facial recognition, definitely no. I have 5 people, I think, who chose facial recognition here, and IAM credentials also no. IAM credentials are for internal AWS services. All right. So let's see if the leaderboard has changed. Okay, we had somebody drop out, and we have RK3. 5 players lost their answer streak of 5. Interesting. So how do I prevent a single user from throttling the system? So AWS account limits, Cloudwatch alarms, Lambda provision capacity, or API gateway usage plans. The right answer is API gateway usage plans. You can also call them quotas if you will. But AWS account limits are for service-wide, limits. Those are, and some of them are soft limits. They can be increased. So, for example, you might have 1,000, concurrency for functions in a given region. But again, that's a soft limit you can increase. Cloudwatch alarms help, but they do not prevent a single user from throttling. I mean, they just provide you the data that you can use to either do automation around it or something. But yeah, that by itself is just more of a notification function. And provision capacity, like I had mentioned, is about maintaining a pool, just like you maintain minimum number of EC2 instances. So you keep the provision capacity ready to prevent cold starts, right? So that is what that is for. Okay, but we had Cloudwatch alarms get 33 responses. That's interesting. Okay, oh, interesting. Elton is the highest climber with 16 places. Okay, and the board has also most of the guys on the board are new. True or false? Security and compliance is a shared responsibility between AWS and the customer. Absolutely correct. It is a shared responsibility. So AWS is responsible for security compliance of the cloud, and customers are responsible for security in the cloud, right? What changes is that when you use EC2 or containers, you're still responsible for containers and applications within the within the EC2 instance. In functions, the internal container layer and all of that is AWS's responsibility. Responsibility for securing your function code as well as the environment around it with IAM and other tools, right? So yes, the level changes, but it is still a shared responsibility. All right, I think we are at the end, and this is the final. Okay, I think we still have a couple of poll questions here. Let me see. All right. So yes, the most important part. I know we talked a lot. This was intended to be an in-person workshop, but because of COVID, we had to move this online. But we still want to know if you enjoyed this session, and if you have suggestions, those are most welcome, because that help us improve how we deliver and what we talk to you about in future sessions as well. Wow, awesome. 81%. Well, this is really good to hear. Appreciate that. But as always, this is just to kind of get, make us feel better, obviously. But what I would request is that, after this session, you will get a survey link, I think an email. Please respond to that. And especially if you have feedback, give us that feedback so that it helps us, deliver content better and figure out the right content to deliver to you in sessions like this. So it will definitely help us improve. So please don't hold back. Please share your thoughts, and that will be appreciated. Okay, so let's see. Vinod, in the final quiz, we have Shash, and the winner is Naveen. Congratulations, guys. And for the winners of the other quizzes as well, great job. I really, appreciate you guys participating. So just quick next steps, key takeaways, and call to actions here. Feedback. Please fill the feedback out. Let us know honestly what you think, what we can improve, how we can do better, and how we can improve sessions, not just the content, but sessions like this, since we are restricted to remote delivery right now. How we can do better, how we can engage with you better, and so on. Right. In terms of reference material, so our talk today was based on the well-architected framework, and the white papers for that are available on the URLs here. And of course, the serverless lens, which was released, like a few months back, that talks about how to apply these principles to serverless applications. That's what we kind of I based my part of the talk today on. And in terms of if you want to get hands-on with some of these, pillars and these principles, please, go to GitHub, our well-architected labs repository. There are a ton of exercises as well as code that can help you get hands-on and in terms of how to apply these principles. But all that said, once all that is done, I think there's nothing like getting real-world hands-on with this. So would really recommend looking at your customer landscape, identifying workloads with them, and validate these architecture principles that we have talked about today against their workload, right? And as always, if you have any questions, feel free to reach out to your PSAs. We're always here we're always here to answer any questions and be of help, right? With that, I think we are done. We will try to see if we can send some of this material to you, after the session, within a couple of days. But that's it from me for now. Ravi, do you want to add any other thoughts before we close?
Guys, this is really great. We had a great participations. Thank you for holding up. We had consistently, participations, and good participations in Kahoot. Good questions we are asking in the chat window. That was nice. Keep it engaging, guys. Please, I have copy pasted the URLs in the chat window. You can use that. Get started, and please feel free to connect to your PSAs and help you. Have a nice time. Stay safe. Thank you.
Thank you. Have a good weekend. Enjoy. Take care. Thank you. Bye-bye.